Hello and welcome to my channel. We are now at the lecture number 9. We are going to discuss about stoichiometry and a very important concept called as principle of atom conservation, which not only helps you to do numericals of stoichiometry, but also helps you to balance equations which are very tough to balance. So with this, let's start. So let's continue now and see what stoichiometry questions are and how to do them. Stoichiometry, how do you pronounce it? Stoichiometry. The topic is stoichiometric calculations. So here we are going to discuss about numericals based on stoichiometry and how to do them. Before we start all of these, let me tell you one very important thing. A simple concept, a question rather. If rupees 5 can buy 8 oranges, of course I'm being very unrealistic here. In sitting at 2021, we cannot buy this, but anyways, if rupees 5 can buy 8 oranges, what is the price of? What is the cost of 20 oranges? How do you solve this question? So please pause the video and do it. And please understand that I'm not interested to know the answer. I'm more interested to know the process because I don't plan to buy oranges anytime sooner. So let's start. Please do it and tell me how many, what money do I need to get buy 20 oranges? Pause the video, do it. Okay, so I hope you have paused and done it. So let me tell you how to actually proceed with this one. See, how to do it? You'll just write like this. If 5 rupees can buy 8 oranges, then 20 rupees can buy, yes, X. Then cross multiply and do it. That's it. So that will give me 8x is equals to this, and this will get multiplied. Always use this technique. And the reason I'm telling you this, you will understand in next 5 minutes. 8x is equals to 5 times 100. I mean 5 times 20. So 8x comes out to be 100 and x comes out to be 100 by 8, which is 12.5. That means we need 12.5 rupees to buy. So therefore, rupees 12.5 would be needed to buy 20 oranges. Again, the process is important. This is called as unitary method. So I'm going to follow this a lot of times in the class today. So let's start with the concept. Okay, so let's go to the concept and see what it is like and how to do it. See, I'm going to give one algorithm. Algorithm seems very fancy nowadays. I'm going to tell you one algorithm to do any question that you have in stoichiometry. Please follow this algorithm to do questions. So the algorithm goes like this. First, write the balanced equation. The first thing is to have to balance the equation and then write it. Once you're done writing the balanced equation, find moles, or I would say find moles or write moles. Write moles and read it. Yes, correct. Read it. After you're done reading, convert moles to mass, as you know how to do it. Right? Convert moles to mass. And then the last step, write the question. Note the question down. Note down the question. That's it. I'll show you. And then use unitary method to do it. Use unitary method. So we have scaffolded the question into these 4 steps. Whenever you get a question, please follow 1, 2, 3, and 4 steps to do any question that comes from stoichiometry. So algorithm to solve stoichiometric numericals or questions. Right, step 1, write the balance equation. Step 2, write moles and read it. I'll tell you what that is. Third, convert moles to mass and then note down the question and use unitary method to solve. Finish. So these are the 4 steps I'll be following, and I'm going to give an example of this. So let's get started. First one example. Suppose I have carbon reacting with oxygen to form CO2. Now, what are the steps I'll follow? So when the question is, this is the question given, the question is, what will be the mass of CO2 produced when 20 grams of carbon burns completely. So suppose this is the question given to you and you have been asked to solve it. So how to do this question? Let me do it in a standard way first. So the way of solution is first write the equation. See, first write the equation and then balance it. Balance it. One carbon on the left, one carbon on the right. So it's already balanced. I don't have to do anything else. It's already balanced. So one carbon, oxygen, CO2. Now, how to read it? You will read it like this. 1 mole of carbon reacts with 1 mole of oxygen to form 1 mole of CO2. This is what I meant when I said you read it. Then convert this to mass. How to convert moles to mass? Mass is equals to number of moles into molar mass. How many moles? 1. What is the molar mass of carbon? 12 grams. Excellent. This will be 12 grams. This will be 32 grams and this will be definitely 44 grams. As per law of conservation of mass, reactant's mass must be equal to product's mass. Okay. Now, then what is the step? First step, add the balanced equation. Write the moles and read it. Convert moles to mass. This is also done. Note down the question. What is the question saying? 20 grams of carbon is being burnt. So we are burning 20 grams of carbon completely. So what amount of CO2 will be produced? Let that be X. Refer to that orange question I gave you. 5 rupees, 8 oranges. 20 oranges, how much? Similarly, 12 gram gives you 44. Or for 44 grams, we require 12 grams. So 20 gram will give us how much? Simple. So if 12 gram give us 44 grams, then 20 grams will give us how much? See, X, same logic, cross multiply. What do we get? We get 12x is equals to 44 into 20. See, and x will be 44 into 12, 20 by 12. So you can cancel it by 3, just by 11. So it will be approximately 76 point something, right? It will come out to be, see, 3 point divided by 11 will give you almost 4, right? So 3.93. So 3.93 into 2. So it will be 6, 8, 78.6. So it will give you 78.6 grams of CO2. Therefore, we can say 78.6 grams of CO2 is produced. This is the concept of stoichiometry. This is how we can do it. Simple. First, balance the equation. Then write the equation, balance it, then find the moles, convert moles to mass, write the given question. Whatever you have to find, put X there like this, and then cross multiply. Excellent. I hope you got it. And this is how we approach a question and do it. Next principle. Let me do the same question in a different technique called as principle of atom conservation. Okay, so let's do it. Next topic is principle of atom conservation. This lecture is all about just getting to know the concept. In next lecture, I'll be doing lots of questions based on JEE Mains, Advanced NEET, and CBSE, on how to do and use these principles to do questions. So principles of atom conservation. It is also sometimes called as POAC, in short form, POAC, principle of atom conservation. What does it say? Very easy. Let's take the same example. C solid plus O2 gas gives you CO2 gas, right? Now, what does the principle say? First of all, let me tell you that principle says that number of atoms of an element on the left hand side of a chemical equation is always equal to number of atoms of that element on right hand side. Simple. This is what it says. So how to approach this? So what I will do is I will now, since I don't know, I'm not going to balance this. In POAC we don't balance any equation. We use this law. Right? I don't know how many moles of A we have because we don't know how to balance it. We have not balanced it yet. We'll write B here. We'll write C here. Okay. That's how any question you have, write A, B, C, D, whatever coefficients. Now, what is the carbon atom balance? Tell me, how many carbon atoms do we have on the left hand side? On the left hand side, we have, see, 1 into A. Do we have any more carbons on the left hand side? Sadly, no. On the right hand side, how many carbon atoms do I have? C into 1, C. So carbon atoms on the left is equals to carbon atoms on the right, which is coming from CO2. So moles of carbon atom from the left hand side is equal to moles of carbon atom from the, which is there in CO2. Simple. Let's make the balance for oxygen atom O. What is the balance of oxygen atom O? So left hand side, our number of oxygen is 2B. See, 2 atoms of oxygen times B, 2B. On the right hand side, how many do we have? 2C. BB gets cancelled. So we have B because of oxygen is equals to C because of CO2. This is how we can use principle of atom conservation always. You can make a balance for oxygen and then write these things. Now, how can I use this for numericals? So let me give this question. First, take a screenshot. Okay, let's go to the next page and see how to do a numerical based on this principle. So question, C plus O2 CO2, same equation, nothing new. If 20 grams of carbon, same question, okay, 20 grams of carbon is burnt completely, find the mass of CO2 produced. Same question. Let's do it. How to solve this question? So if you really want to solve this question, what you can do is you can use that principle of atom conservation. If you don't know how to balance this equation, suppose this was a very difficult one. We will be solving questions, don't worry. For now, just learn the approach. So see, when they burn with each other, when they react with each other, it gives you CO2. Here we don't have to follow any steps. No need to balance, no need to do anything. Just write A moles here, B moles here, and C moles here. Okay, now balance it. What's the carbon atom balance? So carbon atom on the left hand side, we have A into C, A. That's because of carbon. Carbon on the right hand side is C because of CO2, C moles. So A moles of carbon we have. On the right hand side, we have, see, 1 mole of carbon. So C because of CO2. Now, how many moles? How to find moles? Number of moles is nothing but given mass by molar mass, right? Now, see, how many moles of carbon do we have? See, we have been given 20 grams of carbon. See, 20 grams of carbon by the molar mass of carbon. What's the molar mass of carbon? 20, 12. So see, this is what I've done. I found the moles of A because of carbon. On the right hand side, we have moles of carbon because of CO2. So do I have the mass of CO2? No. So let this be the given mass. What's the molar mass of CO2? 44 grams. Finished. That's it. See, done. What is the given mass or the answer? Answer will be 880 by 12 by multiplying, cross multiplying. Same answer. 78.6. 78.6. This is how you can use principle of atom conservation to do any question on stoichiometry. So how to do it? First, balance the equation. Put stoichiometry. No, don't need to balance the equation. Just put ABC. Make atom balance. Any one atom balance will help you to do a numerical. So why don't we do another question and then wind up this video? So let's do another question on understanding how it really works. Suppose the question is nitrogen reacts with hydrogen to form ammonia. This is given to you. They have not even given the equation to you. Then how do you solve it? I know it's an easy question, but I'm going to tell you how to use P.O.A.C to do this. So N2 reacts with H2 to form NH2. The question is, what amount of or what mass of ammonia will be produced when 7 grams of N2 reacts with appropriate amount of hydrogen, meaning whatever amount of hydrogen is required, that is there with you. How to do this question using P.O.A.C? Let's understand how to solve it. See, first thing first, write the equation. N2 reacts with hydrogen to form ammonia. That's it. Do we have to balance it? Not really. Just write A, B, C. Then make atom balance. So tell me, how to balance nitrogen atoms here? Make nitrogen balance. Make nitrogen balance. So how many moles of nitrogen do we have on the left hand side? 2A. 2A. And this A is because of nitrogen atoms. On the right hand side, how many atoms do we have? See, A into C. So 1 into C. That's because of ammonia. Right? Now, out of what is A? A is the number of moles. What is that? Given mass by molar mass. That's nitrogen. What's C? Given mass by molar mass because of ammonia. Right? Now, what's the given mass? Given mass we have is 7 grams. See, what's the molar mass? Molar mass of nitrogen is 28. So 28. See, is equals to, what's the given mass? We don't know. That's what we have to find. What's the molar mass of ammonia? 17 grams. Now cancel it. It will cancel by 2. So what is the answer then? 1 by 2 is equals to given mass by 17 grams. What's the given mass then? 8.5. So given mass will be 8.5, meaning the answer is 8.5. Therefore, we can say 8.5 grams of, answer is 8.5 grams of ammonia is produced. So this is how we can do a question on stoichiometry using principle of atom conservation. So I hope the things we discussed today was clear on how to approach stoichiometry and using principle of atom conservation also. In the next lecture, we'll be doing some questions based on P.O.A.C, some higher order questions of advanced and all on using P.O.A.C and stoichiometry. So if you have liked this video and you've understood the things about P.O.A.C, please like the video, subscribe to my channel and share it to your friends. With this, we'll sign off now. Thank you.